Okay, so part 2, okay, we are going to learn about integrated rate law. Okay, kalau tadi awak punya rate equation is basically dy dx, okay, kalau dalam maths. Then when you integrate it, you're going to put this, kan? So basically you're going to just integrate lah your rate law, okay? But you don't need to know the derivation of your integrated rate laws ni, okay? So we have zero order, first order and second order. So from there we can relate our concentration of reactants with time. So if you need to find concentration of reactants at time t, let's say time is 30 seconds ke 10 seconds ke, then you can use your IRL. Okay, so for the first type of order, zero order reaction, okay, for zero order reaction, the rate is not dependent on the concentration of time, because if you look at your rate law, okay, rate is equals to K concentration of A to the power of 0. So this one will be equal to 1. So awak akan dapat rate is equal to K, and then rate is negative D concentration of A over time, okay, from your chemical equation. And then when you combine both the equations, you will get this, okay. So from here to here and here, okay, there are some derivations that happen, but you do not need to know. You need to know the integrated rate law that you will get, okay. So you need to know these two, okay. So this integrated rate law, let's say if you want to find concentration at time t, you must just insert your initial concentration and rate constant and also your time lah, okay. So make sure they are all in your correct units, okay, dia tally, and then you just do mathematics where you transfer this to the right and this to the left, okay, something like that, and you will get your concentration at time t, okay. Another way to use integrated rate law is by plotting graphs, okay. If you remember y equals to mx plus c, then you can easily get your rate lah, okay. So the first type of graph is for zero order reaction is using rate law, okay. So your rate law for zero order reaction is rate equals to K. So from here you can plot a graph of rate versus concentration, okay. So if you plot this graph, rate versus concentration, you will find that you will get, okay, a straight line like this. It is constant, okay. So when your concentration increases, the rate will remain constant, okay, because tengok sini rate law, okay, awak dapat K je, tak ada pun concentration of A. So rate is independent of concentration of A for zero order reaction. Next, okay, you can draw a graph from the integrated rate law. Yang dua tadi yang kita nampak, the integrated rate law. So the first one here, okay, you can just equate it to y equals to mx plus c, okay. So if you want to find, okay, your rate constant, okay, you can just find your gradient, okay. So your rate constant will be the K, alright. So make sure to transfer this to here to find your rate constant, okay. So yang ni just guna y2 minus y1 over x2 minus x1, okay, to find the slope. Okay, so your second integrated rate law is like this, okay. So instead of y equals mx plus c, you have your a0 minus at time t as your y-axis. So it's right here. Okay, equals to mx, where m is your rate constant and x is your t. Okay, so to find your rate constant, you just have to find the gradient lah. Okay, so ini adalah positif. Okay. Okay. Next. Okay, from integrated rate law, you can also find your half-life. So what is half-life? Half-life is the time taken for the initial concentration to reduce by half. Okay, so A0 is your initial concentration. So the first half-life, okay, your A0 will reduce by half. Okay, so basically awak just masukkan these values into your integrated rate law to get your half-life formula. Alright, so you need to know this half-life formula for each of the order. Okay, 0, first and second order. So for zero order reaction, okay, according to your half-life formula here, your half-life is directly proportional to A0. Okay, maksudnya if you increase your concentration, your initial concentration, your half-life will increase. But in this case, so maksudnya as your reaction proceeds, okay, when your concentration decreases, your half-life will also decrease, but it's directly proportional. Okay, so let's look at this graph of concentration against time. Alright, okay, you will get a straight line graph. Okay, so from this graph here, you can see that this is A0 atas sini. Okay, so for the first half-life, okay, when you reduce A0 to half, which is here, right? Maksudnya half of this. Okay, okay, this is the time. Alright, so the time taken for your A0 to reduce to half is this. Okay, so this is your first half-life. Okay, and then your second half-life, okay, is when this value is half again. Alright, so half again, maksudnya dia akan jadi quarter lah of your original A0. So this one here, this here is the time taken for your A0 to be to get your second half-life. Okay, so this is the time taken yang we are talking about when we are talking about this formula. So what happens bila awak punya A0 decrease? Okay, ni tengah decrease kan? So when your A0 decrease, your half-life will decrease juga. Okay, nampak tak? Ini dia lebih panjang daripada this one. Alright, this is for zero order reaction. Okay, so to identify the order of reaction from half-life method, you will need to know, to remember your half-life formula. Okay, okay, so for this example 8, let's look at it. Okay, the decomposition of ammonia on tungsten at this temperature is zero order reaction. Dia dah bagi tahu dah awal that this is zero order reaction with the rate constant, maksudnya this is your K. Okay, alright, so write the rate equation for the above reaction. I think you can do that by yourself. So rate equation is basically rate law, so you write rate equals to K pasal punya and H3 kan dia zero order kan, so maksudnya ni to the power of 0 lah. Okay, so maksudnya rate awak is basically K. B, what is the half-life of the reaction when ammonia is 0.75 molar? So this one you just use the half-life formula. Okay, masukkan your K and concentration A0. Next, how fast, okay, so that is the rate, is a 0.475 molar of ammonia being changed to nitrogen and hydrogen. Okay, to answer this, you need to look at your rate law again. So this is zero order. So cuba fikir whether your rate will change or not when you change the concentration of ammonia. Okay. Okay. Next is first order reaction. So for first order reaction, the rate is directly proportional to the reactant. So maksudnya, if you double the concentration of your reactant A, okay, then the rate will follow je. It will double. Okay. So basically, kalau dia triple, okay, if you triple the concentration of A, then your rate will also triple. Alright? Okay. So first order reaction, bab-bab awak double ke, triple ke, quadruple ke, dia simple je lah. Okay. But the integrated rate law for first order, dia ada ln. Alright? Dia ada ln. So there are 3 integrated rate laws that you can use, okay, for first order reaction. So macam biasalah, if you want to find the concentration of A at time T, you just need to insert your initial concentration, your rate constant and time. Okay, make sure units are correct. Okay, so also macam zero order reaction tadi, if we can use the integrated rate law to sketch your graphs. Okay, so using your rate law of first order, where rate is equal to K concentration of A, okay, this one will be Y equals to mx. So what is your Y? It is rate, and your X will be concentration, while your slope will be your rate constant. So untuk cari your rate constant, you just have to find the gradient lah. Okay. Okay. But okay, another way for you to know whether you have a first order reaction, if you plot concentration of your reactant to time, okay, against time, you will get a curve graph. Alright. Okay. Next, this one is also the same from integrated rate law. Okay, so you're using your 3 integrated rate law study. Okay, so for this one, okay, this whole term will be Y. Okay, so ini awak letak as Y, and KT will be mx. So X will be your time. Alright, so to find rate constant, macam biasalah, cari the slope. Okay. Okay, so if you use this one, integrated rate law, okay, your rate constant, okay, your slope will be negative K. Okay, so if it is negative K, so just be aware when you want to find K, you need to disappear the negative lah. Maksudnya you have to move the negative to the other side. Okay. Okay, so for first order reaction, okay, the half-life does not depend on A0. So yang ni awak senang sikit ingat. Okay, maksudnya for first order, your half-life will be constant. The time taken for let's say your first half-life, okay, your first half-life will be equal to your second half-life juga. Alright, so this is the formula that you need to know. Okay, remember that. Okay, let's look at the graph. How does it look like? Let's say if you plot concentration against time, macam sini. Okay, this is your A0. So you reduce that to half. Okay, the first half-life is this. Okay, it is this much time taken. And then the second half-life is right here. Okay, and the time taken, okay, will be the same. Okay, this one and this one is the same. So for first order reaction, okay, the half-life is constant, okay, because it is independent of the concentration or initial concentration. So walaupun awak punya initial concentration makin lama makin kurang, okay, half-life awak remain unchanged. It is constant. Okay, maksudnya ini kalau third half-life pun dia sama je dia punya time taken. Okay, so senang lah awak nak identify first order reaction using half-life method ni. Dia sama je. Okay, ingat tu. Alright, so this one I think you can try doing it yourself. Next is second order reaction. So for second order reaction, your rate law will be this way. Okay, so awak ada 2 to the power of 2, alright, exponent 2. So for this one, if you double the concentration of A, the rate quadruples. So quadruples maksudnya it will increase by the factor of 4. Okay, so how do we make this easy? How do we understand this? Okay, if I say double, okay, double, so I will write 2. Okay, since this is second order, then I will write 2 here. So for second order, if you double the concentration of A, it will increase by the factor of 4. Okay, if you triple, okay, the concentration of A who has second order, okay, then the concentration of A will increase by the factor of 9. Alright, and so if you quadruple, maksudnya 4 to the power of 2, then it will increase by the factor of 16. Alright, okay, so that is that. Okay, try to what do you call, process that. Okay, next we have the integrated rate law for second order. So you have 2 here. Okay, you can use whichever you want. It's basically the same, you just rearrange it kan. Okay, then you also need to know how to draw the graph lah, macam first order dengan zero order tu. Okay, using your integrated rate law. Okay, for second order, your half-life formula will be this way. Will be like this. So for this one, your half-life is inversely proportional to the concentration, initial concentration. So let's say when you decrease the initial concentration, okay, since it is inversely proportional, your half-life will increase. So maksudnya bila awak kurangkan A0 tu kan, so bila awak punya graph tu, you will find that awak punya half-life makin lama makin tinggi. So daripada macam ni, dia akan double, dia akan makin tinggi. Alright, so as the reaction proceeds, your half-life will increase lah. Okay, alright, so this is what I meant by the half-life increasing. You can see that this is the first half-life, this is the second half-life. The second half-life is 2 times the first half-life. Alright, dia makin dia double. Okay, alright, so these are the graphs from rate law of second order. So here you have your rate law. So y equals to mx. So you can put x as concentration of A to the power of 2, then you will get a straight line graph. If you put you put x as concentration of A je, then you will get a curve graph like that. Right? So from integrated rate law pula, if you use this one, it will be y equals to, ni adalah mx plus c. Okay, so this is your y-intercept, this is your y, this is your time. So this one here, your slope, okay, will be your rate constant K. Okay. Alright, so this one pun sama je. This one will be Y, this whole term, okay, equals to MX. So, awak punya C tu actually 0 lah kat sini. Okay, sebab tu dia tak nampak, dia tak ada tulis apa kat sini. Alright, so your slope will be, your gradient will be your rate constant. Okay, so, okay, so ini untuk test yourself. Hopefully you try it yourself and you should get these answers. Alright, okay, for example 13, let's look at it. So iodine atoms combine to form molecular iodine in gas phase. The rate constant, maksudnya this is K, of the reaction is this at 23 degrees Celsius. If the initial concentration of I, maksudnya I naught, is this, calculate the concentration after 2 minutes. So this will be your time. Your time is 2 minutes. Alright. So what formula are you going to use? Okay. Macam mana kita nak tahu? First, we have to know the overall order of reaction. Okay. So how do we know? Where can we get? We can get from the unit of rate constant K. So here you have per molar per second. Okay. If you are already familiar with it, you should know that this is your second order reaction. Okay. So now that you know that it is second order reaction, you know what formula, what integrated rate law you can use. You will use your integrated rate law for second order lah. Gunalah mana-mana. Okay. So from there, you need to insert your I naught, initial concentration of I, and your time. So your time is in 2 minutes, while your rate constant is in seconds. So make sure to change your time to seconds. Alright? Okay. And then you perform lah your calculation. Okay, you should get this answer.